Greetings everyone. Today's video will be doing the modeling and finite element analysis of a torsional shaft having circular cross section, and we will be using ANSYS software for this purpose. In ANSYS, we will be selecting static structure. So first of all, the engineering data is there. So engineering data by default has structural steel as the material for our torsional shaft. We'll be using this default structural steel, although we have different options, but we'll just keep it to structural steel. So next we'll have to define the geometry because it's a finite element analysis. There are various steps. So the first step is pre-processing where we'll be defining the geometry, and then we'll go for meshing, and then we'll give the boundary conditions, and then finally we'll have some solutions. So in the geometry, we'll select XY plane. We select on sketching. Since it's a circular cross section, we'll select on circle. We draw a circle here, and then we'll give the dimensions of its diameter. So we select this edge and this surface. So by default, it's 11 point something. Let's just have it as 1 meter diameter. So we move, there we have it, and we zoom in. So here's a circle. This diameter is now 1 meter. Now we'll just extrude it because we want a shaft, a circular shaft. So we select this and we apply. And then how much, let's say we want 10 meters to be the length of the shaft. So as we click on generate it, and then let's just see. And here is our circular shaft, which is going to be a torsional shaft. So the design is done. We minimize this. We go to the model and we'll update it. First things, updating it. So it'll take a little bit of time. Mm. So the design is done. Now the following steps would be meshing, and then we'll go for the boundary conditions, and then finally we'll have the solution. Then next we click on setup, and we'll wait for the geometry to be loaded on the setup. So it has arrived on our setup window. So this is our model which we had defined in the geometry section. Now first things first, we'll just apply mesh on it. So element size, let's just give it 0.1, and we'll click on generate the mesh. The meshing has been done. We can further refine the mesh. Click on mesh, insert, and there's refinement, and it asks for the geometry. We'll select the whole body. So this was a body, and we select the whole body, and the geometry we apply, right? Okay. We have to select it individually, and there you have it. So three faces, and then generate, and the mesh has been done, has been defined. So let's go on static structural. Now, first things first is that there is a fixed end. So there has to be a fixed support. So we click on static structural, insert, and then fixed support. And now for that fixed support, let's just give, this is the face which is at the origin. You select on face, you select on this face which is at the origin. We select apply, and now this face has become the fixed support. We also have, since it's a torsional shaft, it will have a torsion acting on its free end. So again, static structure, we go insert and we give moment. Now for moment, it will be acting on the edge of this free surface. So we select on edge, we select which edge, apply, and this edge has been selected. Now for the moment, let's just we'll define it by its component, and it will have a z component because for the twisting moment, it has to be the direction has to be positive z or negative z direction. So let's just give 20 Newton meters as the moment, and we see that a moment, this red arrow, moment has been applied. So the moment has been done. We'll also have a force acting on the same free surface. So again, static structure, insert, and we have force. So we click on force, and then again this surface. Now force acts on this surface. So this is the free surface. We select the free surface. We click on apply. This face has been selected. Now we'll define again this force with help of components. For we'll have only the z component for easy understanding of the problem. Let's just have 50 newtons acting on the positive z direction. Plus 50 means it's acting on the positive z direction, which would be outside of this face. Right? So we have defined the three conditions. So we have a fixed support, which is this face. We have a moment acting on the free face, and we also have a force which is acting on this free surface. Okay. So now for the solution, now we have the mesh, we have static structure, we have defined this. Now we are in the solutions. First solution, we click on solution, insert, and then let's just have total deformation. We'll also have the directional deformation. Let's just also have some stress and also the strain. Let's have strain. For strain, we'll have equivalent or the bond basis strain. And even for the stress, when we click on stress, we'll have the equivalent or bond basis stress. So all these parameters we need to calculate. So we click on solve. And then we have our results in here. Let's see first total deformation. We'll have a smooth contour for easy understanding. So here is our total deformation. For the values, we see that the minimum total deformation is 0 meter, which happens to be here, which was a fixed end. So at the fixed end, the total deformation is minimum, which is 0. There is no deformation at the fixed end, and it is maximum at the free end, where the moment and the force are acting. Even for the directional deformation, this is the contour. For the equivalent elastic strain, we have this. This was the free end. So on the free end, we have a maximum of 1.23 into 10 to the power 8, right? And the minimum is on the fixed end. Similarly, for the stress also, on the fixed end, there is a minimum stress, and on the free end, we have a maximum stress, and the values are given here. So this was the final result of the modeling and finite element analysis of the torsional shaft, which is having a circular cross section. Thank you.